The following question asks us if the diode is a limiter circuit, a voltage doubler circuit, none of these, a peak detector circuit, or a DC restorer circuit. And for this, we're going to turn to the notes that are linked below the like button. So for limiter circuits, we have something that looks like this. We have a limit down here and a limit up here. We have a slope of our L and K, and then we have these values here that determine where we're at along our V out, which is the y-axis, and our V, I think this is like a V input, which is our x-axis. Then we have a sine wave right here, and this sine wave is going to be limited by our L plus and our L minus, and that is how the limiter circuit works. So diodes can be used to create limiter circuits. They limit how high and how low a signal can go. We can see that with the sine wave right here. The gain is set by the reset of the circuit, which is an op amp that can be used. Here, on the right, a sine wave is limited by the diodes to make it look more like a square wave, and this is helpful in phase locked loops, PLLs, and communication circuits. So we have specific types here. Notice the use of our 0.7 right here, the continuous use of it. And this is because the voltage of our diode, a battery with the voltage of our diode, is 0.7. So we can just assume that a diode has 0.7 volts. And we see the slope here is 1 over 1. That's what we had previously. We have a V out over V in. So when our diode is off, the V output we can see is going to be the same as our V input because this is going to act like an open circuit. So the current's just going to flow through just like this. It's going to be the same thing across this voltage right here. And then when we get to 0.7 right here, when we get to this point, that is when the diode is switched on. When the diode is switched on, the current is going to be limited. Now we have the same thing for this next one, except the diode is inverted in our circuit. And what this means is that when our diode is off, so until it hits this threshold, where we're at the 0.7 volts, the current is going to flow through here, and it's going to be the same voltage as our diode. And once our diode is on, it's going to stop this, and it's just going to increase like this, as if it were an open circuit right here. So it was a short circuit, then it's an open circuit. Next, it's going to be a combination of them both. So it's going to be the same thing. It's going to be a voltage divider with two diodes. So we have D1 and D2. One is going facing down and one is facing up. And this is so we can limit it like how we have it here, and limit it how we have it like this. If we want to kind of amplify this, we would have another battery right here. Remember, we have voltage across our diode, which is 0.7. And then we can add a 5 volt voltage across it like this. So everything else is the same. We're using the voltage divider. We have voltage here, we have a resistor, we have a voltage output. And now we have the diode, which acts as a resistor in series with our voltage output right here. And so all this is going to do is it's going to, you can notice how the diode is facing downwards, like how it is up here. So that means it's going to, the input is going to be the same as the output until it reaches where our diode is, which is 0.7. But since we have this battery in series with it, we have to add the voltages, so it's going to be 5.7. So it's going to limit at 5.7 here, and it'd be the same thing if we had this diode right here, just the opposite direction. So if the resistor in parallel with the diode, what happens if we have another resistor right here? Well, when we are not hitting the limit of the diode does not matter. So we still just have voltage division. So let's look at this. Limiter circuits. Is that going to be one of them? Well, we can see that it is not any of these options here. So limiter circuits is not going to be one of our options. Next, we're going to look at peak detectors. Diodes are often used to create peak detector circuits, which output the max peak value of an integer voltage. So we have our diode here, and we have a capacitor here. When the diode is on, it's going to charge this capacitor. When it's off, the capacitor is going to drain, and we can see that with the graph right here. So when our V inputs, we look at the graph, it goes positive, the diode turns on, and C charges to our VP, which is the peak value. And this is the peak value of our VI, which is our sine wave. So VI is our sine wave, VP is the peak right here. When VI drops from its peak value, the diode turns off and C state changes to VP until a load or leakage current discharges it. This is useful in communication circuits, power supplies, etc. However, even though we have our capacitor here, we have a capacitor here, and we have two diodes, we can see that this is not going to be a peak detector circuit. So this can be crossed off as well. It's neither a limit circuit or a peak detector circuit. Next, we can look at a DC restorer circuit. And this is also referred to as a clamped capacitor circuit. We can see that this is more like what we have here. However, it's still not the same. Since the diode turns on right here, and it's going to, if the diode turns on, prevent our V0 from being less than 0 volts, the capacitor charges up to its peak negative value of V input, which is the negative 6 volts. So in this example, VC is equal to plus 6 volts, since the minimum is of V1, V input is equal to negative 6 volts. Ideal diodes are assumed here for the ease of understanding. When V input rises, the diode is going to turn off, and V out goes up to the total charge and voltage V input. This is useful for restoring DC values to AC coupling signals and etc. However, again, like we said, this is not like what we have here, so this is not going to be one of our options. So now we can keep looking. Is it a voltage doubler circuit, or is it none of these? Well, for a voltage doubler circuit, it looks something like this. You can see it's very similar here. We have our voltage, we have a capacitor, we have our diode 1, diode 2, and C2. We have also our V out here. So by combining a clamped capacitor circuit and a peak detector circuit, which look very similar to these, we can build a voltage doubler. So C1 and D1, which are tied right here and right here, they form the clamped capacitor circuit. And then our C2 and D2 form the peak detector circuit. So when D2 turns on, it's going to charge our C2 to be negative 2 VP for our example right here. The V output is going to be 2 times our V input. So this V is going to be, or V out actually, is going to be equal to 2 times V. And this is useful to create voltage which is greater than our VDD. An example for this is flash memory. So for this example, we've solved it, and we know our answer is the voltage doubler circuit.